Hello everyone, very good evening. This is Sanjay Rathi. Now guys, I'm going to start this series that is GATE 2025 preparation, and this time that exam is conducted by IIT Roorkee, and previously 2009 and in 2017 GATE was conducted by what? IIT Roorkee. तो यहाँ पर हम लोग स्टार्ट कर रहे हैं प्रीवियस ईयर क्वेश्चन ऑफ 2009 and 2017, and I'm going to start with one of the most important subject, that is network or what? Circuit theory. So let me know that sound quality, picture quality, everything is fine guys. Yes please. First of all, please join the session now. Okay, so I'm going to solve some important questions, and with these questions I will give you the idea which type of question we can anticipate in coming exam. आप गेस कर सकते हैं कि कैसे क्वेश्चंस आएंगे, क्या पैटर्न है, एंड डोंट ट्राई टू मग अप. क्वेश्चन को रटने की कोशिश मत करो, क्योंकि टॉपिक्स रिपीट होते हैं, क्वेश्चंस रिपीट नहीं होता. ओके, तो आप यहां पर बस एक आइडिया लगाओगे कि किस टॉपिक्स की इंपॉर्टेंस है, कहां से क्वेश्चंस आते हैं, राइट. और आईआईटी रुड़की का माइंडसेट कैसा है, वी कैन डिकोड हियर. ओके, तो चलिए स्टार्ट करते हैं हमारा सेशन. ओके, एंड देन एवरीवन प्लीज, if you have any suggestion or if you want to give any comments, then yes, in comments box you can give your comments also. Okay, then guys, this is my introduction. Myself Sanjay Rathi, 24 years of teaching experience, and I have trained more than 1 lakh students, and I have qualified and selected for engineering services exam. These are my ranks. Okay, and these are my area. Now try to use my experience, and if you want to crack this exam with the top rank, then remember guys, there is no shortcut. आपको कुछ प्रैक्टिस करनी होगी, एक सेट पैटर्न जो है उसको फॉलो करना होगा, क्वेश्चन सॉल्व करने होंगे, प्रीवियस ईयर क्वेश्चन सॉल्व करने होंगे. अगर ये सब आप रूल फॉलो कर रहे हैं, देन यू आर गोइंग टू क्रैक दिस एग्जाम गाइज. नाउ this is my telegram channel where I will upload the PDF of this session, so you can join my telegram channel, that is electronics by Sanjay Rathi. Okay, link is given in description, you can join now. Then that is the first question, network theory previous year question 2009 and 2017. This is the first question from electronics branch, and remember, network is common for what? Electronics, electrical and instrumentation. So I am going to solve questions from all the 3 branches. The first question is from electronics. Then what is the statement? Fully charged mobile phone with a 12-volt battery is good for 10-minute talk time, right? Then assume that during the talk time the battery delivers a constant current of 2 ampere and its voltage drops linearly from 12 volt to 10 volt. This is that it is dropped from 12 volt to 10 volt. How much energy does the battery deliver during this talk time? So you have to find what is the what is the energy delivered by that. Okay, अब आप बनाइए कैसे ये क्वेश्चन बनेगा, देखते हैं जरा. फर्स्ट ऑफ ऑल, जब भी आप क्वेश्चन बना रहे हैं तो जो न्यू स्टूडेंट्स है वो ध्यान रखिए, प्रॉपर स्टेटमेंट देखो कि इसमें क्या क्या की पॉइंट है. फुल्ली चार्ज मोबाइल, व्हाट इज दिस? 12 वोल्ट बैटरी, एक 12 वोल्ट बैटरी लगी हुई है. कितने मिनट का टॉक टाइम है? 10 मिनट का टॉक टाइम है. लेकिन जब हम एनर्जी निकालते हैं तो इट शुड बी इन सेकंड, तो इनटू 60, तो दैट इज व्हाट? 600 सेकंड. 600 सेकंड का टॉक टाइम है. एज्यूम दैट ड्यूरिंग द टॉक टाइम द बैटरी डिलीवर्स अ कांस्टेंट करंट दिया हुआ है, आई इज कांस्टेंट, एंड वोल्टेज वेरिएबल है. वोल्टेज कहां से कहां तक वेरी कर रहा है? 10 वोल्ट टू 12 वोल्ट, 12 टू 10. हाउ मच एनर्जी डज द बैटरी डिलीवर? अब सबसे पहले यहां है वोल्टेज वेरिएबल है, और एनर्जी डिलीवर्ड का क्या फॉर्मूला है? एनर्जी इज इक्वल टू व्हाट? इंटीग्रल ऑफ पीडीटी, 0 टू 2. टी हमको मालूम है 600 सेकेंड है. अब पी क्या है? पी जो है वो है वीटी इंटू आई टी. अब I यहां कांस्टेंट है, एंड व्हाट अबाउट द VT? VT वेरिएबल है. तो एक तरीका यह है कि आप VT की क्या निकाल लो? इक्वेशन निकाल लो, राइट. इसकी स्लोप अगर आप पता करेंगे, और स्लोप के साथ आप जैसा कि जानते हैं, व्हाट इज द इक्वेशन ऑफ द लाइन? Y इज इक्वल टू mx प्लस c. आई एम गिविंग यू द वन ऑप्शन, देन देयर इज अनदर वेरी इजी मेथड. y is equal to mx plus c. What is the x here? T. What is the slope of this line? in a 10 step it will reduce from 12 to 10. So what is the change here? 2. So what is the slope? y2 minus y1, that is the 10 minus 12 upon x2 minus x1, 10. So it will become minus 0.2. It is a negative slope, right? Negative slope. And that's why this equation will become Vt is equal to V on a y-axis, and that is what is the slope here? Minus 0.2. X is time plus c. What is the c here? Interception with the y-axis, that is the 12. That is what? 12. तो यहां से आपको ये पता चल गया Vt is equal to, that is the equation, minus 0.2 and so on. Now you can put the value. You can put the value E is equal to 0 to 600. I is constant. What is the constant current? 2 ampere into Vt. What is the Vt? Minus 0.2t plus what? 10 plus 12 dt. Now you can integrate and put the limit and you will get the answer. First method. Now one thing is variable here, voltage. So directly we can find what? Area of this curve. So with the help of area it will become very easy. Otherwise you can verify the answer with this integration. You can do this integration. Now what is the second method here? If this is required, Vt here, so I is constant, so you can write E is equal to what? I you can take constant, that is the 2 integral 0 to 600 Vt dt. And what is the meaning of the Vt dt? Area under this curve. So what is the area of, if you have the idea, you can find the area of this triangle plus area of this square. So what is the area of this square? 10 into 10, 100. And what is the area of this triangle? Half of base into height. Half of base is 10 into height. What is the height of this? 2. So 10. So what is the area total? 100 plus 10, that is the 110. It will become 2 into 110. But remember, here the time is given in what? Minutes. And you have to convert it into what? Seconds. So you have to multiply it with what? 60. 10. Please find use your calculator and you will get the answer for this question. Because here you have to use this 10 into what? 60. It will become what? 600. So when I am taking the common, in both the cases, you have to multiply it with what? 60. Right? So that will become 0, 0, and that is the 66 into 2, that is 132 joule and 13.2 kilojoule. So that is the answer. Yeah, this is the answer, 13.2, and this is of 1 mark question guys. Very very simple question, 1 mark question. तो देखिए नेटवर्क में ऐसा नहीं कि हर क्वेश्चन टफ आएगा, आपको कुछ क्वेश्चंस बहुत इजी भी दिखेंगे. तो ये दैट इज वन टाइप ऑफ क्वेश्चन. देन नेक्स्ट वन, और अगर आप इंटीग्रेट भी करेंगे तब भी आपके पास वही आंसर आएगा, आप वेरीफाई कर सकते हैं. देन आते हैं नेक्स्ट क्वेश्चन में. अब देखो अगला क्वेश्चन भी, पहले आप ये चेक करो कि भाई नेटवर्क का जो पहला है सिलेबस बेसिक, वहां से भी आपके पास क्वेश्चन है. तो बताइए इसका आंसर क्या होगा. एवरीवन टेल मी व्हाट विल बी द आंसर फॉर दिस पर्टिकुलर क्वेश्चन. रीड करो क्वेश्चन, बताइए क्या होगा आंसर. गिव मी 1 मिनट. Yes. Now, in the interconnection of ideal sources shown in the figure, it is known that the 60 volt source is absorbing the power. Where is the 60 volt? This one. Absorbing power. Which of the following can be the value of the current source I? तो जितने नए स्टूडेंट्स हैं जो सेकेंड ईयर में हैं, थर्ड ईयर में हैं या फाइनल ईयर में हैं, जिन्होंने गेट फर्स्ट टाइम दिया है, तो देखो कितना बेसिक सा क्वेश्चन है. सबसे पहले यहां पर एक कॉन्सेप्ट ध्यान रखो कि कोई भी पावर एब्जॉर्ब कब कर रहा है. मीन्स this is plus, this is minus, that is voltage. If current enter through the plus and leaving the minus, then it will absorb the power. Then it will absorb the power, and it is given by V into I, positive value. And it will absorb the power. This particular, it may be capacitor, inductor, resistor, or any other element, battery, voltage source, and so on. And if suppose this is the plus, this is minus, this is V volt, but current entering through the minus and leaving the plus, then it will deliver the power. What is the delivering power? Minus. Normally it is represented by minus convention. ये है ना, तो ऐसा नहीं कि हर बार आपको यूज ही करना है. अब डायरेक्टली यू कैन से यस पावर डिलीवर्ड बाय दिस सोर्स एंड हियर द पावर एब्जॉर्ब्ड बाय दैट. तो चलिए देखते हैं जरा व्हाट इज द पावर. तो व्हाट इज द आंसर हियर? इसका क्वेश्चन का तो आपको जवाब आना चाहिए. व्हाट इज द आंसर फॉर दिस क्वेश्चन? नाउ अब आते हैं जरा क्वेश्चन में. 1 मिनट. ये रहा डायग्राम आपके पास में. यस प्लीज. फर्स्ट ऑफ ऑल watch this. What is required? What is the value of the I? If suppose it will deliver the power, right? It will deliver the power. What is given here? Absorbing the power. 60 volt source is absorbing the power. Absorbing power means what is the direction of the current? That is the direction of the current, Ix. Now this current will become I plus Ix. I plus Ix. That is equal to what? 12. This is the incoming current. We are applying the KCL. This is incoming. This is incoming. That is the outgoing. So I plus Ix is equal to what? 12. So what is the value of the I? 12 minus Ix. Means we are subtracting something from the 12. Means it is less than 12. So this is a MCQ type question, multiple choice question. And that's why which answer is less than that? Only one answer is less than that. That is the 10 ampere. And that's why this is the answer. Right? This is the answer. Very, very simple question. So we have used this concept. What is the power absorbed? This is power absorbed and that is power delivered. And what should be the direction of the current? Okay. अब भाई देखो, I am going to continue this session as well as part 2 for network, then analog part 1, analog part 2, then what? Digital part 1, digital part 2. I am going to cover questions from 3 branches. इलेक्ट्रिकल, इलेक्ट्रॉनिक्स एंड व्हाट? इंस्ट्रूमेंटेशन ब्रांच. तो आप मेरे साथ बने रहिए और क्वेश्चन कैसे बनाना है वो समझिए. रटने की कोशिश मत करो, क्योंकि रटोगे तो वो क्वेश्चन तो बन जाएगा लेकिन जो एग्जाम में आएगा वो नहीं बनेगा. ओके, तो ध्यान रखिएगा. देन अब आते हैं जरा नेक्स्ट क्वेश्चन पर. अब है ये देखिए, न्यूमेरिकल आंसर टाइप क्वेश्चन, NAT. अ कनेक्शन इज मेड consisting of a resistance A in series with a parallel combination of resistance B and C. ये भी देखिए, that is the question from very basic, right? A connection is made consisting of a resistance A in series with a parallel combination of resistance B and what? C. 3 resistors of value 10 ohm, 5 ohm, 2 ohm are provided. Consider all possible permutation of the given resistor into the position A, B, C and identify the configuration with maximum possible overall resistance. First of all, how many marks? Only 1 mark question. How many lines? 1, 2, 3, 4, 5, 6 line question. So which are the important point? Underline it. 10, 5, 2 ohm and in because it is a computer based test, तो आप क्या करो, अपने रफ में नोट कर लो क्या इंपॉर्टेंट डेटा दिया हुआ है. 10, 5 and 2 are provided. ABC, what is the reason? कैसे कनेक्शन किया है? A in a series with a parallel combination of resistance B and C. तो देखो, A आपका सीरीज में है और पैरेलल कॉम्बिनेशन ऑफ B and C. ये B रजिस्टर है, ये C है, ये A है और A 10, 5, 2 ये वैल्यू है. किसी पर्टिकुलर उसकी वैल्यू नहीं है, आप किसी को भी ऐसा यूज कर सकते हो एज ए ABC 3 वैल्यूज को. देन also the one with minimum possible value and maximum possible value, the ratio of maximum to minimum value of the resistance up to second decimal places. यहां पर क्या लगाना है भाई? एप्टी का यूज करना है. तो फर्स्ट ऑफ ऑल देखो, सीरीज में अगर इफ यू वांट मैक्सिमम, always remember when we are connecting the resistor in parallel, value of the resistance will decrease, and if you want maximum then put the maximum value here, because when we are adding in series always maximum resistance. And then we can put the 5 parallel with what? 2. If suppose you are going to put the 10 here, parallel with 5, it will reduce the value of the 10 also. So what is this? 10 plus 5 parallel with 2. This is the maximum resistance. Maximum. So it will become 10 plus 10 divided by 7 and that is the 70 plus 80 by 7. This is the maximum value. Now what is the minimum value? For minimum value, you have to put the minimum resistance in series. That is the, what is the minimum value? 2, 5 and 10. Okay, and you will get the minimum value for that. Now 2 plus 5 parallel with 10. What is the 5 parallel with 10? 50 divided by 15, that is the 10 by 3. This will become 16 by 3. Now maximum divided by minimum means 80 by 7, 16 by 3. 80 by 7 upon 16 by 3. तो ये हो गया 5 and this is what? 7, sorry, 5 into 3 divided by what? 7. 15 by 7. Right, so 2 point something. And that is the answer up to 2 decimal places. But in answer they have given the range. ये आपका आंसर आ गया है 2.413. ठीक है, चेक कर लीजिएगा. 1 मिनट, कहाँ गया भाई? ये आंसर है. ओके, दिस इज द आंसर फॉर पर्टिकुलर क्वेश्चन गाइस. तो यही आएगा ना? यस, ये है, दैट इज द आंसर. तो वेरी सिंपल लॉजिक यू हैव टू अप्लाई. Maximum and what? Minimum. Now next level. So remember we can divide the syllabus. First basics, KCL, KVL, mesh analysis, nodal analysis, parallel connection, series connection of the resistor, parallel and series connection of the capacitor and so on. These are the basic parts of what? Circuit theory और network. तो यहाँ से क्वेश्चन आएंगे. सेकेंड आपका पार्ट आता है, फिर आपका एंटर करते हो आप किसमें? थ्योरम्स में. स्टडी स्टेट एनालिसिस ऑफ साइनोसॉइडल सिग्नल, 2 पोर्ट नेटवर्क, ट्रांजिएंट एंड सो ऑन. तो यहां से भी आपके क्वेश्चन से देखते हैं जरा कैसे हैं क्वेश्चंस यहां. फिर आते हैं जरा, ये देखिए, इन द सर्किट, दिस इज 4 ओम. In the circuit shown, what value of RL maximize the power delivered to RL? That is on the maximum power transfer theorem in 2009 2 marks question. Now basic over, question from theorem. What should be the value of RL for maximum? So what is the rule here? You have to find what? RTH, and this is the VTH, that is called Thevenin's equivalent of the particular circuit up to A and B. Then according to maximum power transfer theorem, RL should be equal to what? RTH. If you want the maximum power, then RL should be equal to RTH. Right? Now, means you have to find the Thevenin's resistance. What is the rule for the Thevenin's resistance? First, make the battery active source, independent active source 0. You can make it what? 0. Okay. You can't make it 0. What? Because this is a dependent source. Vx 4 ohm, 4 ohm. Now you can replace RL with open circuit. Remove the RL. You have to make the RL infinite. Vs 0, RL infinite. Now Vs becomes 0. Now you can put a battery of 1 volt. That is the method. Battery of 1 volt. And that this is the current I. Okay, and you have to find RTH is equal to what? V by I, that is 1 by I. That is called RTH. Now, watch carefully. This is 4 ohm, this is Vx, this is 4 ohm, this is Vx. So, both the path have the similar, right, similar elements. 4 ohm, Vx, 4 ohm, Vx. So, you can say, you can divide the current I by 2, I by 2. If this is the case, I by 2, I by 2, now you can write a KVL in this loop. You can write the KVL in this loop. When I am writing the KVL in this loop, it will become 1 is equal to I by 2 into what? 8. This is the 4 plus 4, 8. And directly you can say 1 by I is equal to what? 4 ohm. And this is the value of RTH, and therefore what should be the value of RL? 4 ohm. Value of RL should be equal to what? 4 ohm. C is the answer. अब किसी को लगेगा सर अगर मैंने ऑब्जर्व नहीं किया देन ऐसा हो सकता है ना कि अरे सर ये तो दिखा ही नहीं मुझे डायग्राम में, ये 4 ओम, ये Vx है 4 ओम, Vx 4 ओम, 4 ओम, इट इज आल्सो Vx, सो देन एंड इन दैट केस method will remain same. Short circuit, remove the RL, right? You can connect a 1 volt battery here. Let this is the current I. Now in that case we have no idea what will be the current. Now you can say what is the current here, because this voltage is what Vx. So you can say that current through this branch is Vx by 4. What this is the 4 ohm, and what is the voltage Vx? So what is the current here? Vx by 4. Now what is the current here? You can say I minus Vx by 4, because that is the Vx by 4. So what is the current here? I minus Vx by 4. Okay. Now you have no idea about the what is the relation between I and Vx. So you can write 1 KVL in this loop, right? So suppose I am going to write 1 KVL in this loop. This is the 4 ohm. So you can what? You can write 4 I minus Vx by 4. 4 into I minus Vx by 4 plus Vx, right? Now it is minus Vx, and just suppose I am going like this. This is the minus, so it will cancel, right? It will cancel. Okay. So or kaun sa KVL, if you want to find the relation between that, you can put 1 KVL here. 1 KVL here. From this KVL you will get the relation between what 1 volt and Vx, or what I or what Vx. Write down the KVL here. Then it will become 1 is equal to Vx by 4 into Vx. Vx by 4 into 4 plus what? Vx. Then this is cancelled. So 2Vx is equal to 1, and that's why what is the Vx is equal to 1 by 2. Vx is equal to 1 by 2 volt. Now you have the value of this battery, right? Value of this battery, a value of this Vx 1 by 2, then it will become I minus 1 by 8. Now write down 1 KVL in this loop, and you can find what is the 1 by I. So that is the another way. But first of all, observe circuit carefully. Observe what circuit carefully, and then you can find the value, guys. Okay. अब आपको दिख रहा है यहाँ पर आ गया 1 by 2 drop. So what is the drop here? 1 by 2. So you have to find the relation between I and V, and that's why you have to use this KVL. You have to use this KVL. So here I'm going to write here 1 is equal to 4 times of I minus 1 by 8, because Vx is equal to 1 by 2, plus 1 by 2. Okay, and that KVL is over up to this point, and then it will become 1 by 2. This is the 1 minus 1 by 2 into 1 by 4 is equal to I minus 1 by 8, right? 1 by 8 plus 1 by 8, that is equal to I, that will become 1 by 4. I is equal to 1 by 4. So what is the 1 by I is equal to 4 ohm. You are getting the same answer. अब प्रॉब्लम क्या है? प्रोसीजर लेंदी हो गया, इतना लंबा आपको बनाना पड़ा, जबकि डायरेक्ट ऑब्जर्वेशन से यू कैन डायरेक्टली से द आंसर फॉर दिस क्वेश्चन इज व्हाट 4 ओम. कुछ अदर आ जाए तो आप इस तरीके से सॉल्व कर सकते हो. ओके. If for any detail, that is my number 9899940096, or you can join my Telegram channel, that is Electronics by Sanjay Rathi. ओके. और अगर आपको कुछ कोर्सेज ज्वाइन करना है तो भी आप इस नंबर पे मुझे मैसेज कीजिए. वन सब्जेक्ट इज गोइंग ऑन, दैट इज व्हाट एनालॉग. पूरा डिटेल में आप लोगों के प्रीवियस ईयर क्वेश्चंस के साथ, और जो भी आपको सॉल्व करना है, जो भी आपको मेथड समझना है, फॉर डिटेल यू कैन मैसेज मी एट दिस नंबर about fee, about course structure, and how we are going to cover this subject, each and everything. Then अब आ गया ये क्वेश्चन का आंसर 4 ओम. नेक्स्ट क्वेश्चन देखिए, दैट इज ऑन 2009. देखो सिमिलर टाइप ऑफ क्वेश्चन इन 2017 2 मार्क्स. Similar type of question in 2017 2 marks question, again the paper from what? IIT Roorkee. तो देखिए, consider the circuit shown in the figure. the Thevenin's equivalent resistor across PQ. You have to find what is the Thevenin's resistance across P and Q. If you want the Thevenin's resistance, guys, then what is the method here? What is the method here? First of all, to find the Thevenin's resistance, you have to make this what? Short circuit. Which one? This voltage source. If suppose you are going to make independent sources 0, voltage source means short circuit, it will short circuit this 1 ohm resistor. Both are short circuited because it is parallel. Second important thing, if you have any resistor parallel to what voltage source, whether it is a dependent or independent, this is a current controlled voltage source and we have 1 ohm resistor parallel to it, and at the same time we want relation between applied voltage 1 volt and I. What is the 1 upon I? That is called RTH. 1 upon I. Then you can remove this resistor also. No need to consider because it is connected parallel to that. So suppose we are making it very simple diagram. ये आपका आ गया सिंपल, इसने इसको शॉर्ट कर दिया, ये 1 ओम यहां आ गया, ये 1 ओम यहां है, एंड दिस इज I नॉट 1. ये वाला जो 1 ओम है ये शॉर्ट हो गया, इसको हटा दीजिए. शॉर्ट नहीं हुआ है, इसको रिमूव कर दीजिए. यहां पर एक डिपेंडेंट सोर्स आ चुका है 3I नॉट, and that is what? Parallel 1 volt, and this is I. Now guys, what is the I naught? I naught will become 1 volt, this is the parallel, divided by 1 ohm, 1 ampere. Now this will become 3 into 1, that is the 3. Now you can write a KVL in this loop. When I am going to write a KVL in this loop, then this will become I minus, this is the I minus I naught, and what is the value of the I naught? 1. So I minus 1, I minus I naught, I minus 1, write down the KVL. Same current will flow here, I minus 1. So 1 is equal to, this is 1 is equal to 3 I naught, that is nothing but 3, plus 1 into I minus 1. Now it will become 1 is equal to 3 plus I minus 1, that is the 2, and this is the minus 1. So what is the I is equal to? You are getting minus 1. If I is equal to minus 1, then what is the 1 by I? I is equal to minus 1, then what is the 1 by I? Minus 1. So RTH you are getting negative. Is it possible, everyone? Tell me. Minus 1 ohm. Yes, it is possible that we are getting the negative resistance. If you are getting the negative resistance, means what? That particular circuit means what? Suppose I am giving you one diagram, try to understand. Let this is the diagram, this is RL. Let the RL is 5 ohm and that is 10 ohm, and we are having the 10 volt here. Then what is the voltage across the RL? So according to voltage division rule, RL upon this plus RL, 10 plus 5 into what? 10. And you will get the 50 divided by 15, that is the 10 by 3, that is less than what? 10 volt. So that is what attenuation. We are getting less voltage than what? This 10 volt. But if suppose you are having the negative resistance, suppose you are having the negative resistance. For example, this is the VTS 10 volt and here you are getting the negative resistance. And that's, we are having the same value of RL at 5 ohm. Okay. And let this is the minus 1. Now apply. What is the voltage across the resistor? RL upon RL plus RTH into Vs. What is the RL? 5 upon 5 minus 1. 5 minus 1 because it is negative into what? 10. You will get 50 divided by 4 and that value 12.5 is greater than what, 10 volt. Greater than what, 10 volt. So in this diagram it is attenuation, means we are getting less than the VTH, or in this diagram we are getting more than the VTH. More than the VTH, and that is the output voltage. So it will amplify the signal, we can say. So this is a negative resistance. For amplification we are getting the negative resistance. If suppose same value, that this is the -5, this is 5, this is -5 and this is 5. If suppose you are going to put the same value, what will happen? Tell me. 5 RL upon 5 RL minus RTH is -5 into 10. Guys, 5 minus 5 means what? 0. 5 by 0 it will become infinity. If we are having this type of resistance, means no need to apply any input, we are getting the output, and that is the case for oscillator. That is the case for what? Oscillator. And oscillator gain should be what? Infinity. So if RTH is negative -5 and this is equal to what? RL magnitude, then you will get the gain infinite, and in that case we can make a oscillator circuit, and that is the concept of what? Negative resistance device like tunnel diode, gun diode and so on. तो नेटवर्क का कॉन्सेप्ट आप यहां यूज कीजिए. नेक्स्ट क्वेश्चन, नेक्स्ट वन. So what is the answer for this question? -1. Answer for this question is -1 guys. Negative resistance. अब आते हैं जरा नेक्स्ट क्वेश्चन पर. अब आगे देखो, दैट इज द क्वेश्चन फ्रॉम द theorems. Now the question from study state analysis of sinusoidal signal. And guys, remember this is the paper of what? Electronics branch. Means we are having the question from the study state analysis. This all the questions from electronics branch, and in second part means tomorrow at the same time 8:30 we will solve question from electrical and instrumentation branch. So how many students are interested? Please write in comments box. तो अभी जो इलेक्ट्रॉनिक्स है वो सॉल्व कीजिए, देन इलेक्ट्रिकल एंड इंस्ट्रूमेंटेशन, एंड रिमेंबर नेटवर्क इज कॉमन फॉर ऑल 3 ब्रांचेस. तो देखिए, an AC source of RMS value 20 volt, this is given, and this is the phasor 0 with internal impedance 1 plus J2, that is the value. This is the resistor RS ZS, its internal resistance. Feeds a load of impedance 7 plus J4, this is the value in the figure. Reactive power consumed by the load is, what is the reactive power consumed by the load? So here we are going to use this concept. That power means we are giving the complex power S is equal to what? P plus JQ. Here it is called effective power or average power or resistive power. Here it is called reactive power. Reactive power, and that is called complex power, and magnitude of S is called apparent power. This is called apparent power, magnitude of S. We have to find the value of Q. Now, how we can find? This is the value is given by I RMS square into what? Z. I RMS square into Z. Okay. So we have to find what is the power, the reactive power consumed by the load. So you have to use the Zn. Then from that you can find the reactive power. Remember, this is the average or effective power. Now how we can find the magnitude of I RMS square? First of all, what is the total impedance? Zs plus Zl. It will become 1 plus J2 plus 7 plus J4, and that is 8 plus J6, right? And then what is the magnitude of Z? It will become root over 8 square plus 6 square, that is 64 plus 6 root 100, and that is what? 10 ohm. This is the magnitude of this. Now what is the 20 volt RMS value? 20 volt is the RMS value. So if you want to find the RMS, no need to, this is what? Total I will become what? V by Z. V by Z. So you have to find the angle also. So we have, this is a complex, so this is the magnitude, and that's why that z is represented by magnitude of z, angle of theta. This is the theta z. What is the theta z? You can find tan inverse of imaginary upon real part, 6 by 8. That is the 3 by 4. You will get around 36. But no need to find the angle. No need. Don't waste your time. You have the magnitude of that, so you can find the magnitude of IRMS directly. This is the IRMS value. Why IRMS? Because V is the RMS value. This is given 20 divided by magnitude of Z is 10. So what is this? 2. No need to find the angle. Then 2. Now what is the square of the 2? 4. And what is the ZL? ZL is 7 plus J4. So 7 plus J4. So what is the S is equal to 2 square IRMS plus ZL 4 into 7 28 plus 4 into 4, that is 60. This is the effective power, and that is what? Reactive power. So reactive power is 16, and what is the unit of the reactive power? Volt ampere reactive. Volt ampere reactive. Yes. Rather, analog classes just within 1 or 2 days, right? 1 or 2 days. I am going to just I will inform you about that. Okay. 1-2 दिन में ही हो जाएगी चालू. बहुत ज़्यादा प्रॉब्लम रहा तो सैटरडे एंड संडे आई एम गोइंग टू स्टार्ट. ओके. देन ये आ गया आपका 16 VAR. अब आते हैं जरा नेक्स्ट क्वेश्चन पर. Then ये at a very high frequencies the peak output voltage is again in 2017. That is the question on what capacitor at a high frequency. We can say that is the question on steady state analysis of sinusoidal signal, right? Or we can say that is a question on what transient, but it is a very basic question. It is on question on elements, that is about the capacitor. Or this is given at a very high frequency. So normally when it is nothing is mentioned, we are talking about what? Steady state. At steady state. So steady state means ZC is equal to 1 by omega C. ZC is equal to 1 by omega C. What is the value of the C? Watch this. C is very small, 100 microfarad, right? If the C is right small, as well as what is written here, high frequency, at very high frequency, nothing mentioned. A high frequency, what is the meaning of the high frequency? It is in the range of mega ohm, giga ohm, right, or 10 to the power 15 or more than that, nothing mentioned. If the frequency is very high, what will be the impedance? Because it is inversely proportional. If this is very high, so what about the impedance? Very low, or you can take it what? Nearly equal to 0. Nothing is mentioned. That's why all the capacitor will act as what? Short circuit. All the capacitor will act as short circuit. That is a very basic question on this, and this is the sinusoidal signal. All the capacitor, if they will act as short circuit, this is short circuit, this is short circuit, this is short circuit. Now 1 kilo ohm in parallel, that is the 0.5 kilo ohm, this is the 0.5 kilo ohm. And what is the voltage here? 1 sine of omega t. This is the peak value, 1 sine of omega t. So what is the voltage across this? This is 0.5 kilo ohm, this is 0.5 kilo ohm, half of this. So 1 by 2. So that signal will total will become 0.5 sine of omega t. And what is the peak value of the output? 0.5 volt. That's why the answer is what? 0.5 volt. तो देखो क्वेश्चन में ना कई बार कुछ भी मेंशन नहीं है, नथिंग मेंशन. Very high frequency, the peak output voltage. What is the meaning of the high frequency? Very high. Means what about the impedance? It will become 0. You can take it what? Infinite, then it will become 0. That is the concept. तो कई बार ऑब्जेक्टिव आपको ऐसा बनाना होता है. तो दिस इज द वैल्यू, इट विल बिकम व्हाट 0.5 वोल्ट. देन नेक्स्ट क्वेश्चन. अब आपको कॉन्फिडेंस आ रहा है. देखो आईआईटी रुड़की ने पेपर कंडक्ट किया था 2009 एंड 2017 का. क्वेश्चंस हर टॉपिक पर आए हैं. क्वेश्चंस आया है फ्रॉम द बेसिक, क्वेश्चंस फ्रॉम व्हाट थ्योरम्स, थेवेनिन्स, especially Thevenin's and maximum power transfer theorem. Then question from what steady state analysis of sinusoidal signal. बस एक ही चीज मिसिंग है यहाँ पर, टू पोर्ट नेटवर्क. तो कोई बात नहीं, टू पोर्ट नेटवर्क इज अ इंपॉर्टेंट टॉपिक, इजी टॉपिक, तो यू कैन कवर. नाउ अगेन क्वेश्चन फ्रॉम व्हाट वी कैन से steady state analysis of sinusoidal signal in 2017, 2 mark question. 100 cos of 3t. Remember 3 is what? Omega. Omega is 3 radian per second. Omega is a 3 radian per second. This is given. What is asked? The figure shows a RLC circuit excited by a sinusoidal voltage of 100 cos of 3t, where t is in a second. The ratio of amplitude of V2 divided by V1. V2 amplitude of V2 divided by V1. Let this impedance, you can say let it is the Z1. Let this impedance is Z2. So what we can write here, 1 minute. Yes. Let this is Z2. This is Z1. This are connected in series and that's why the current is same. So what is the V2 by V1 or V1 by V2? What is asked here? V2 by V1. Amplitude of V2 divided by amplitude of V1. You can write I same, cancel. This is the 2, this is 1. So this is the simple ratio of what? Z2 by Z1. Z2 by Z1. This is the simple. Okay. Now, what is the omega here? 3. So simply V2 by V1 means that is the ratio of magnitude of Z2 and magnitude of Z1. How you can write the Z2? Z2 here it is a capacitor. This is the 5 ohm. So R minus J by omega C. So this is the 5 minus J by 3. Omega is 3 and what is the C? 1 by 36. It will become 12. So this is the 5 minus J12. What is the magnitude of Z2? Root over 5 square plus 12 square, that is 144 plus 5, 25, right? 169. And what is the 169? Root 13. 13. तो ये तो एकदम सिंपल है, हर बार ये आएगा Z2. What is the Z1 here? R plus J omega L. This is R and this is what? J omega L. R value is 4 ohm. J omega is 3. What is the value of the L? 1 Henry. It will become 4 plus J3. What is the magnitude of this? Root over 4 square plus 3 square. 16 plus 9, 25. What is the root 25? 5. So that ratio will become 13 by 5. That ratio is what? Z2 by Z1, 13 by 5. And what is the 13 by 5? 2.6. Yes. So that is the V2 by V1 will become 13 by 5. That is nothing but 2.6. 2.6. अब देखो इस क्वेश्चन में कई लोगों को डर लगता है, जैसे वो देखते हैं ना, इंडक्टर लगा है, कैपेसिटर लगा है, रजिस्टर लिखा है, तो क्वेश्चन एकदम कॉम्प्लिकेटेड होगा एंड सो ऑन. ऐसा नहीं है. आप वहां पर सिंपल सा कॉन्सेप्ट लगाइए, सिली मिस्टेक अवॉइड कीजिए एंड यू विल गेट द आंसर, राइट. तो ये इसका आंसर है 2.6. नाउ नेक्स्ट क्वेश्चन. अब देखो ये है ओनली 1 मार्क क्वेश्चन, सेट 2 on RLC circuit. In the circuit shown, V is in a sinusoidal voltage source. The current I is in a phase with voltage V. Current I is in a phase voltage V. the ratio of the amplitude of voltage across the capacitor by amplitude of voltage across the resistor. What is the voltage across the capacitor and what is the voltage across the resistor? You have to find the amplitude, means what? Vc by VR. Ratio you have to find Vc by VR. Now remember, question on what? Series resonance. कैसे बोल सकते हो रेजोनेंस में? तो V and I, देखो क्या लिखा है, V is a sinusoidal voltage, the current I is in phase with the voltage V. Phase with voltage V means what? There is no phase difference between V and I, means circuit is under resonance. Remember, V and I, when V and I are in same phase, means circuit is under resonance. For more detail, you can watch my session on series resonance, guys. Link is given, or you can press I button, then you will get the link of that. Okay, series resonance. अब यहाँ पर series resonance का concept आ गया. Then under series resonance, what will happen? Impedance of ZL, this is मतलब magnitude of ZL and magnitude of ZC are equal. And what is the resonance frequency? 1 by root over LC. 1 by root over LC. So you can find the resonance frequency 1 by root over 5 into 5. And that will become what? 1 by 5. This is 1 by 5 radian per second. If suppose the resonance frequency is asked, then you can directly find this one. Now what is the asked here? Vc by VR you have to find. In a series, current will remain same. So what is the Vc by VR? Vc by VR means you can write I, magnitude I, or directly you can write like this into ZC. Then R. This is cancel out. You have to find the ZC by R. So what is the ZC? 1 by omega C. And what is this R? So you can find 1 by omega R C. Okay. Now you have the value of omega, you have the value of R, you have the value of C. What is the omega resonant frequency? That is what already I have given. What was the resonant frequency? 1 by 5. What is the value of R? 5. What is the value of C? 5. And that is 1 5 is cancelled, 1 by 5, that is the 0.2. 0.2. Now what is the 1 by omega naught RC? 1 by omega naught RC is nothing but quality factor for resonance frequency. This is, we are just finding the quality factor Q. You can put here root over LC omega 1 by omega and RC into R, that is C. Now 1 by omega RC, 1 by LC, sorry. Omega is what? 1 by LC. Root over LC. Now you will get 1 by R root over L by C. And that is the formula for what? Quality factor 1 by R root over L by C. Again you will get the same answer, that is the 5 5 cancel, and you will get the 1 by 5. And what is the quality factor? 1 by 5, that is nothing but 0.2. So next time remember, Vc by VR is the value of what? Quality factor. VL by VR is the value of the quality factor. Why? Because under resonance, the magnitude of VL is given by Q times of magnitude of Vs, and Vs is equal to what? VR. Value of VR is equal to Vs under resonance. Vs is the applied voltage. This is the Vs or V. Similarly, what is the Vc? The magnitude of Vc is given by Q times of Vs, right? And that's why you can write Q times of VR. And therefore, what is the Vc by VR? Q. Directly you can use omega naught R C. L by C. ओके, दैट इज द फॉर्मूला। ये निकाला है जो मैंने, ये याद रखिएगा। तो फॉर मोर डिटेल already I have given a link, please go through the series resonance. Within 10 to 15 minutes you will get the command over the complete series resonance topic. Press I button, you will get the link for that. Now next one is, next question, watch this one. The switch in the circuit shown was on opposition for a long time and is moved to position at B. Right, switch A, this is the position, it is at A for long time and is moved to position B, exactly at t equal to 0. The current IT for t greater than 0 is, where is the current IT here? अब ये क्वेश्चन कहां से है? That is the question from transient. This is the DC transient, this is the DC value. Already we have solved question from steady state analysis of sinusoidal signal, theorems, basics. Now question from transient in 2009, 2 marks question. I am just solving the topics, right, sequence. Chapter 1 basics, steady state analysis, theorems, then what, transient. Tomorrow again at the same time we will solve question from electrical and instrumentation branch, same sequence. अब देखते हैं under transient. My dear friends, which is at position A for long time. Long time means what? Circuit is under steady state. Under steady state, what will happen? Under steady state, capacitor will act as open circuit. Now, can we find what is the equivalent capacitor? Yes, you can find the equivalent. These two are in parallel and that is in series. Sometimes we are making very big silly mistake here. Right? What is the silly mistake here? Just I am giving you the hint that, okay, yes, this is the diagram. What we are doing, normally students are 0.5 plus 0.3 plus 0.2 and they are finding the C equivalent 0.5 plus 0.3 plus 0.2, that is 1 microfarad. That is the problem. Right, and you will get the one answer from this. Second, what we are doing the mistake, we are connecting just like resistor. These are in parallel, so 0.5 parallel with 0.3. So we are, what we are doing just like a resistor, 0.3 upon 0.5 plus 0.3 plus what, 0.2. This is the C equivalent. Both are wrong. So what is the right method? What is the right method? These two capacitors are connected in parallel. So this will become 0.5 plus 0.3 is equal to what? 0.8 microfarad. This is the 0.8 microfarad. That is in series and that's why the C equivalent will become 0.2 into 0.8 upon 0.2 plus 0.8. That is the series connection. It will become 0.16 divided by 1 microfarad. Means 0.16 microfarad and that is the value of the capacitor first of all. Now this complete combination is converted into a single capacitor. Under steady state, this capacitor will act as what? Open circuit. And switch is connected to A. Then can you find the voltage across this capacitor? 100 volt, because this combination will charge by what? 100 volt. And that is the diagram for T0 negative, just before the switching. Just before the switching. And what is the nature of capacitor? Capacitor does not allow sudden change of voltage. ये sudden change allow नहीं करेगा. So VC0 negative is equal to VC0 positive. It will remain 100. Next time you can make a diagram like this. You have the complete value of the capacitor, equivalent value, and this is the resistor. What is the value of this? 5 kilo ohm. What is the value of the equivalent capacitor? 0.16 microfarad. And what is the voltage? This resistor will, this capacitor will discharge through the resistor. It is a source free RC circuit. So what is the final voltage? 0. Finally the capacitor will discharge through that. What is the initial voltage? Capacitor does not allow sudden change of voltage. So initial voltage 100 volt. And what is the equation? V final minus V final minus V initial e raised to power minus t by tau. Tau is the time constant. What is the time constant? RC equivalent. R is 5 kilo ohm, 5 into 10 raised to power 3, 0.16 microfarad, means 10 raised to power minus 6. Then you will get 16 into 5, and then this is, you can write here, what you can write, guys, this is 0.8, okay, and then, am I correct? Yes, 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 and this is the into 10 raised to power minus 3. 10 raised to power what? Minus 3, that is the time constant. Then what will be the equation? V final is 0, V final is 0, V initial is 100, e raised to power minus t by 0.8 into 10 raised to power minus 3, that is the 1000 divided by 8, or 10,000 divided by 8 is 1250, e raised to power 1250 t. तो कोई है क्या आंसर भाई? अच्छा, अब मैंने क्या मिस्टेक की है बताओ जरा. What is the mistake here? The switch in the circuit was an option A. For a long time it is moved to the position at, everything is fine. What is asked here? मैंने निकाला है अभी वोल्टेज की इक्वेशन, बट व्हाट इज आस्क्ड हियर? व्हाट इज द इक्वेशन फॉर द करंट? What is the equation for the current? Okay, so I have find what equation for the voltage, and that this type of mistake is what called silly mistake. So read question carefully. What is right here? Current IT, and I have find what voltage. Now if you have the equation for the voltage, what will be the current here? I voltage divided by what? Resistor. So what is the current here? VC by R. What is the value of the R? 5 kilo ohm. 100 by 5, it will become 20 e raised to power minus 1250 t milliampere, because resistor is in kilo ohm, and that's why we are getting the current in milliampere. So this will become 20 e raised to power minus 1250. Now what will be the direction? Same direction, because the capacitor will discharge through resistor. So that will be the direction, positive direction, IT. So now this is the answer. 20 e raised to power minus 1250 ut milliampere, guys. Ut means it is applicable for t greater than 0. This equation is applicable for t greater than 0. अब आपको कोई भी डाउट है यहां तक तो पूछिए, ऐसे आपको क्वेश्चंस बनाना है. अब आते हैं जरा नेक्स्ट उस पर, एक दो क्वेश्चन और, बाकी रिमेनिंग क्वेश्चन हम लोग कल सॉल्व करेंगे भाई, राइट? याद रखिएगा, रिमेनिंग क्वेश्चन इन पार्ट 2. नाउ नेक्स्ट वन. The time domain behavior of an RL circuit is represented by L di by dt plus RIT is equal to V naught 1 plus B e raised to power minus RT by L sin of t ut. Okay, अब लिखा क्या है? For an initial current of V naught by R, the steady state value of the current is given by, what will be the steady state value? So I am giving you the hint. Try to solve this question and give me the answer in comments box. Watch this. There are two ways to solve this question. Under steady state, what will happen? What about this term? Because it is transient, steady state means what? T is infinite, and that's why this term will become 0. This term will become 0. Second thing, if the applied signal is what constant value, then at under steady state, then what about the rate of change of the current? The rate of the change of the current is what? Rate of the change of the current will be 0. That's why you can make it what? 0. So what will be the steady state value of the current? That is the V naught by R. Directly you can say, or you can find steady state by using the Laplace. What is the Laplace of this? L di by dt. So what is the initial value of the current? V naught by R you can write here SL L, what is the Laplace? SIS minus initial value V naught by R. This is called Laplace of what? Di by dt plus RIS is equal to, that is the, it will become V naught. What is the Laplace of this? 1 by S. What is the Laplace of this term? B. And this is the sine of t. What is the Laplace of sine of t? Omega upon S plus A. S plus A. What is the A? Power of that? R by L. Plus omega square plus omega square. What is the omega square? This is the 1 square. And that's why this omega will also become 1. That is the sine omega t. So omega will become 1. So I'm going to write this Laplace. I'm just giving you the hint. Now, after this Laplace, find the value of what? Is, right? And then apply the final value theorem. What is the final value theorem? Limit t tends to infinity is equal to it is equal to limit s tends to 0 s of is. S of is. So from this you can arrange it and find the is. Omega is equal to 1. Apply here and then put the s is equal to 0 by multiplying this, and you will get finally V naught by R. So which method is easier? Try to solve this question, guys, and write answer in my comments box. Okay, that is important. Then I'm giving you the 2 or 3 assignments. Then tomorrow I'm going to solve this. This is the answer. Now here in the circuit shown, the voltage is described by this one. For t less than 0 it is 0. For t greater than, it is 15 volt. Means initially that circuit is unenergized. There is no battery is connected. What about the initial current through the inductor? 0. Inductor does not allow sudden change of current. Okay. For t greater than 0, what is the voltage applied here? 15 volt. Now, the time at which the current I in the circuit will reach the value of 2 ampere is. Which current? Current through the 2 Henry. It will reach to what? It will reach to 2 ampere is. Now, what is the initial current through this? 0. What is the, suppose you want to find the time constant of the circuit. So these two inductors are connected in parallel. So what is the parallel combination of the inductor? It will become 2 into 1, that is the L1 into L2 upon L1 plus L2. That will become 2 by 3 Henry. Right? 2 by 3 Henry. And what is the resistor here? 1 ohm. What will be the time constant? L equivalent by R. So 2 by 3 upon 1. So that is the 2 by 3 second is the time constant. 2 by 3 second is the time constant. Now, once you have this, under steady state, both the inductor will act as short circuit. So that circuit under steady state is this much. And what is the voltage here? For t greater than 0, it is 15 volt. 15 divided by 1. So under steady state, what will be the current? Finally, under this is called steady state current. 15 divided by 1, that is the 15 ampere. 15 ampere. Now, what is the equation for Is? I is given by I final minus I final minus I initial e raised to power minus t by tau. Right? ऐसा आ गया आपका. अब I final means what? Final is what? 15. 15 minus 0 e raised to power minus t by tau means 2 by 3. Finally, you will get 15 1 minus e raised to power minus 2 by 3 by 2t. Okay. But remember guys, this is the total current and you have to find current across the 2 Henry, means you have to apply the what? Current division rule. So what is the current division rule? I is given by, that is the current through 2 Henry, the total current divided by L1 plus L2, 1 plus 2. And if you want the current through this, then you have to multiply with this L1. What is the L1? 1. And that's why it will become IS by 3. What is the current? 5, 1 minus e raised to power minus 3 by 2t. And that is the equation of the current through the inductor, L2. Okay. Now, what is the question here? Question here, the time at which the current I in the circuit will reach the value of 2 ampere. So, at which time it will reach to the 2 ampere, then finally, at this point write 2 ampere. 1 minus e raised to power at 3 by 2 T1, you have to find the T1. So 5 minus 2, that will become 3. This is what, and you have to please find the value of the T1. You can put what? Log and so on. So please try to solve this. I'm solving for you. That is, this will become 2 by 5. Watch this. Okay, is equal to what? 1 minus e raised to power minus 3 by 2t. Then it will become 1 minus 2 by 5 is equal to e raised to power minus 3 by 2t. 1 minus 2 by 5. And that will become 3 by 5. And then you can write 3 by 2t is equal to what? 5 by 3. Change the reciprocal and then put the log. And then guys, what is the value of the T1? T1 will become 2 by 3 times of log of 5 by 3. 2 by 3 times of log of 5 by 3. You have the calculator, find the value. You have to use the virtual calculator, remember. So try to solve this question and give me the answer. If you have any other method, you can apply the Laplace. Just I have given you the time domain analysis. And finally, you will get the answer 0.3405 second. In 0.3405 second, it will reach to what? 2 ampere. Very quickly, you can solve this question, right? If you have the idea about the current division rule and what is the final value of the current, very quickly, you can find the value at which time it will become. But remember, most important thing is what? Time constant. Some students, what they will do, they will find the time constant for this, time constant for this. Remember, पूरे एक सर्किट के लिए एक टाइम कांस्टेंट होगा जिस तरीके से मैंने आपको निकाला। तो ये क्वेश्चन बहुत ही इंपॉर्टेंट है, ध्यान रखिएगा। तो आज के लिए इतना ही दोस्तों, ठीक है। आपको मैंने एक क्वेश्चन असाइनमेंट दिया है, एक और ये क्वेश्चन है, दिस इज फॉर असाइनमेंट, दैट इज फ्रॉम 2017 एंड 2 मार्क्स क्वेश्चन सेट टू गिव मी द आंसर। इफ यू वांट टू सेंड योर डिटेल्ड आंसर देन यू कैन पोस्ट ऑन माय टेलीग्राम चैनल, दैट इज इलेक्ट्रॉनिक्स बाय संजय राठी। तो मैं आपके आंसर चेक कर लूंगा कि आपने कैसे कौन सी अप्रोच लगाई है। द करंट इन 5.5 सेकेंड यू हैव टू फाइंड फॉर दिस पर्टिकुलर सर्किट। दिस इज माय नंबर 9899940096 फॉर डिटेल अबाउट एनी पेड क्लासेस, जैसे कि एनालॉग चल रही है, आपको कुछ डिटेल चाहिए तो आप इस नंबर पर मैसेज कर सकते हो। ओके, और देखिए इनका जवाब आपको कहाँ मिलेगा? नेक्स्ट क्लास में, दैट इज द पार्ट 2 गेट 2025 प्रिपरेशन IIT रूड़की 2009 एंड 2017 प्रीवियस ईयर क्वेश्चन नेटवर्क पार्ट 2 टुमारो शार्प एट 8:30 PM. Okay, then finally guys, thank you for joining the session. Stay tuned with us, subscribe our channel and like the session. Thank you.